Alright, good afternoon everyone. Welcome to today's Sec 4 E-Math lesson with me, Teacher Jason over here. As always, be willing to take for your lesson in particular. Now, let's get on to today's lesson, shall we? Let me come out again and let's start for today's lesson. Alright, so before I start today's lesson, just a few things. Just be patient and understanding, observe gracious and respectful behavior even in digital space. And lastly, ask good and relevant questions in particular for today's lesson. So what are we going to go through for today? Alright, so just a little note over there. There is going to be a live study Q&A session coming out in the next 5 days. Alright, so mark down the dates. 5 days left to actually mark this date for your live Q&A so that you'll be able to benefit more. If let's say you want to ask any questions, study with the teachers there. You will be they will be more than happy to help you if any of the queries from there. 3rd August, mark the date. 5 days left there. Alright. So what are we actually going to go through today in particular? Okay, we are actually going to revise our some notions of statistics over here. So starting from what we have covered from the Sec 1 and Sec 2, the different statistical diagrams that we have went through, and following up from there, going to averages and comparing what you have learned in Sec 4 recently, standard deviation, what is the median, lower quartile, upper quartile, what we have covered, and some analysis, specifically these two things over here. Okay, so quite a bit to revise, but let's get on to it, and hopefully all these are coming back to you, alright? So the first few recaps later on, what I'm going to go through, are basically diagrams definitely that you have seen. So, the first few diagrams, statistical diagrams, I hope you recap them. You have seen them in your Sec 1 syllabus, which is your bar graph, alright? So, in your bar graph, you have your vertical axis. Take note, we don't say y-axis over here because it is not labeled y. Vertical axis, depending what is labeled. Horizontal axis, depending what is labeled as well. I didn't say x-axis. All these are the details. And the bar graph over here, the widths are equal over here. And also, the height thus tells us how much is it. So in this case over here, tennis will have 40 students. And for golf, in this case, can anybody tell me how many students will there be? Anybody want to try? What is the number for golf? How many students will there be? Alright, very good. Alright, so we realize golf over here, if you were to measure, it's a halfway point between 60 and 40. Very good, Chen Zheng, is 50. That's right. So that's where we measure golf over here. So you need to know how to read these from there. Similarly, if we switch to the line graph, it's very similar over here, just that it is actually useful to see the trend. January is 40, April is 50, July is 50 over here. In this case, it's a 3-month trend. So they are able to see the trends, which is what you're not able to do in the bar graph. Alright, certain things I'm stating over here. Again, don't say x-axis, don't say y-axis, x-axis, horizontal, vertical. Moving on, next one, your pie charts. Yes, so pie charts, this is your Sec 1 knowledge over here. Sometimes they can display it in the form of your angle. So pop in this case is 110, jazz is 90 degrees. But depending on the number of students, okay, you can find out how many people actually like pop, jazz, rock, hip hop in this case, depending on the title over here, and as well as mainly even though they didn't give you the total, you can also get the percentage. Similarly, bringing down the pictogram as well, depending on the number of books shown over here, you can find the percentage. But in this case, depending on what is given here, if this represents 20 books, in this case, self-help will be 30 books. And can anybody tell me for history? History is a tricky one. How many books will there be for history? Does anybody want to give it a try? History. Are you sure 50? Take note, Chen Zheng, look very closely. History, is it 50? It's a quarter of a book for history. So how many of them is it? Yes, Chen Zheng, very good. Okay, so take note, it's 45. So just take note over there, it's 1/4 of a book. Again, a very good recap, but I hope you got it there. No worries, Chen Zheng. That's where we all know. Following up next, we have a dot diagram. That's where you'll see in your Sec 2. Alright, dot diagram. So over here, this just tells you the actual amount of data that you actually get for specific cases. In this case, age of students in the camp. You have one student that is 10 years old, 3 students, that's 11. So basically, you just count them. And also another way, stem and leaf. Okay, this is the stem. This is to count the 10th digit. Or depending how many numbers are written here, can be 100, thousands. But the leaf over here is usually written as the 1th digit. So the key over here, if they say 10 represents $10, in this case, these are your money. So in this case, say for example, if I were to have 2 and 5, what does it represent? Okay, 2 and 5, okay, represents, what does it represent over here? Okay, very nice. Okay, so I think some of you all got it already. You have 2 and 5. Okay, Chen Zheng with the perfect answer, 25. That is good. So that's how you read your stem and leaf diagram. Hope you are recapping over here. Last 2 diagrams before we go on to our first bubble question for today. Okay, so we have 2 different histograms. One is ungrouped, one is grouped. Most of them are almost the same. But can anybody tell me in particular, for ungrouped and grouped data, what is the difference? What is the difference over here for histogram for ungrouped and grouped data? Okay, so again, same thing. You have a vertical axis, you have a horizontal axis, they are the same. Very good, Denise. So you realize my group over here, there is a certain range. So over here, we are talking about 140 to 145. But at the bottom over here, you realize for ungrouped data, there's only one value. So sometimes data can be displayed either ungrouped or grouped data, because for ungrouped, we are able to say a specific number. Somehow your students only are 140 cm, 150 cm, so on and so forth. But we know that is not going to be the general case. We know our height is going to be in a range. So therefore, in certain cases, group data may be more accurate. And also, in certain cases, ungrouped data may be more accurate. Okay, so with all these statistical diagrams, what are the questions that may come out? The next 2 bubble questions will emphasize on that. So let's get on to it with the first bubble question for today. Alright, so they didn't tell you the angle for croissant, but you don't really have to, because all these 3 are given. You can find for croissant. But look at the question carefully. I'll start the bubble launcher in a while, launching it in 3, 2, 1. Let's go. Alright, let's go. Let's see how are the responses. Alright, that's good. Okay, 1 down. That's good, that's good. Okay, so look at the question very carefully. And what does the question want? Very carefully over here. Alright, so I have 40 more seconds. Key in your responses. Alright, that's good, that's good. Remember, pie or macaron? What does it mean? Very nice. I would say most of you got it down. Last 20 seconds. Look at the question carefully. What does the question want? Last 5, 3, 2, 1. Okay, not too bad. Most of you got it down, but take note, look at what the question wants. They prefer pie or macaron. So that means we are actually looking at this specific section, because either pie or macaron. So I'm looking at either the student likes pie or macaron, but I'm not too sure. So I'm just covering both of them under the red color section. So what do we need to do? Once we identify that, we need to find a percentage. So a concept of percentage is actually encompassed in this particular question. So percentage of students, in this case, that prefers pies or macarons. So that, okay, just write down the statement so that you are clear. Pie or macaron. Okay, so this is in degrees, so make sure when you do your division, it's 84 degrees plus 42 degrees. Okay, some of you all went to find for donut. Take note, look at the question carefully. I want pie or macaron. Some of you went to find pie only. Take note, I need to add macaron. Okay, remember, pie or macaron consists of both. Either pie or macaron, so I need to consider both situations. Multiply, remember, because it's percentage, 100%. Take your calculator, press it, you're gonna get 35% over here. Okay, that's the answer. Now, maybe one type of question I can add on to this is it accurate in this case? Let's say, Okay, maybe not for this question. You will see on later how we analyze the data of a specific statistical diagram, which you will see almost at the end of the lesson. I do not wish to go too much into that. Okay, now you realize, back to this question, statistical diagram with percentage. What is another way they can test you? Next one, another statistical diagram, but take note, look at it carefully. I'm looking for probability. Okay, key term over here, selected random, at least 172 cm. All right, launching the bubble launcher, you have 1 minute. In 3, in 2, in 1, let's go. All right, very nice. Some of you got it down already. So I'm looking at the probability of at least 172. All right, moderator, it is all good. I'm recording on OBS already, so thank you for the reminder. All right, most of you got it down. That's good. For the rest, give it a shot. At least 172. Okay, some of you are not looking at the question carefully. I want at least 172. And some of you are falling into the trap, so take note. Last 10. All right, hang there with me. Last 5. Last 3. Okay, some of you are falling into the trap. Okay, very nice. So take note, when I say at least 172, right? The word at least tells me, do I include the value of 172 or not? Okay? So when the word at least comes into play, we include, because the least number is 172. So I'm including the number 172 cm. So therefore, the values I'm consider, it's 172, 172, 175, and 7, and the rest as well. Once we consider these numbers, the total number, in this case, you realize all of them, it's 15 at the bottom. How many of them I have at the top? 8 of them. So that's why this is my answer. So that's why some of you actually did number 3. Number 3, take note, is greater than 172, which means I did not include this. Henceforth, 6 over 15, which is 2 over 5. Some of you actually answered the other way, 3 over 5. 3 over 5 is at most. So the most value is 172, so you might have considered these branches instead. So just take note on how you actually read the question accordingly. But so far, good response over there. Just keep it up and let's move on. So statistical diagrams, depending on the questions, they can mix up with probability, percentages, but most importantly, how you read them. Moving up further, averages of statistical data. So how do we recall calculating the mean, median, and mode? First things first makes things easier. We rearrange it in ascending order. So rearranging it, we get this notion over here. So 14, 17, 18, 20, 22. So I'm just rearranging it. So once we have that, can anybody tell me how do we calculate the mean of this particular data set over here? How do we do it for this particular data set? Okay, or if you were to, if you are unsure on, or if you want to tell me the general way of calculating the data set, how do we do so for this particular question? Okay, so again, let me give you a hint. A mean is something like a fraction over here. So there's something you need to put at the top and something you need to put at the bottom. All right, so at the top, what do we do? All right, I'm seeing some responses. Very good. Okay, so I think most of you are excitedly answering already. At the top, we are actually just summing all the numbers. And how many data sets do I have? How many data sets do I have? Can anybody tell me? Very good. Sum up my frequency, in this case 8. And therefore, Chen Zhen giving me the answer 20.75. So mean is actually sum of all the data sets divided by the number of data. Next one, median. In this case, how do I calculate the median? Now, median, there are two ways. One, if it's odd data, one is even data. Very good, Chen Zheng. In this case, this is an even set of data. So, how do we do it? If you realize, median is the value in the middle. So, you realize my middle data is here. But it cuts in between 20 and 22. So, what we need to do, we take the average of these two data sets, which is 21. That's how we got it, and go jiao Chen Zheng. But let's say I switch the question a little bit. Suppose I actually don't have 29. What is the median now? Suppose I don't have 29. Let me just remove this over here. I'm going to remove it later. What would be the median now if I remove 29 from the data set? Very good, Chen Zheng. Anybody else wants to try? Very good, Denise. I think most of you got it. Anyone else? Alright, I think most of you got it. Good job, good job. Okay, so you realize the middle of my data over here, it's the one that separates the data into two different sets. In this case, an odd set of data, I want to find a number that splits it equally into two different sets. So in this case, it's 20 if I remove the data set 29. But then again, let's not confuse, so let me just remove everything over here. And this is the notion. Lastly, mode. This should be rather straightforward. What is the mode of this data set over here? Okay, what do I have? This is rather straightforward. I have the data sets over here. What is the mode? Very nice, Chen Zheng. Awesome. Anyone else? What is the mode? Okay, it's 20 something. That's a hint. Okay, 20. Very good. Okay, most of you got it. 23. Okay, very good, Denise. I think you missed out too, but it's okay. Don't worry about it. Because mode is just the most frequent data value that appears. And it just so happens every data set appears once except for 23. That is why that's the mode. So I hope with this example, it is a bit clearer on what's the mean, median, and mode. And let's see how strong your concept is when it comes to such a question. Now, again, you realize, teacher, this has nothing to do with the topic recap. How do I even start off with this? That is why you have to put a thinking cap and ask yourself, what do these things actually mean and how do they help you to solve for this question? All right, it is 2 minutes long. Do your best. I'm going to launch it right now. 3, 2, 1. Let's go. All right, this is a little bit hard, yeah? So do it slowly. Make sure you read the questions carefully. Question carefully. Don't rush it, all right? Read the data carefully. All right, I think some of you got it. That's good. Okay, take note. The mean is 8. Highlight the key information. Median is 7. Mode is 6. Important thing, how many data sets you have. This is very important, especially for median. Okay, and then the last one, a little bit tricky right here. Smallest number is half the largest number. Alright, oh, looking at the responses, some of you got it down. That's good, that's good. Alright, from this question, you can actually straight away decipher something already. Some of the options can actually sort of be removed. Okay, last 50 seconds hanging there with me. Okay, doing okay, doing good. Okay, hang in there. For those of you to answer, you have about 30 seconds with me. Just hang in there with me. This is a little tricky. And in fact, this is actually modified from a particular O-level style question. Sounds like this is a little trick over here. Last 10 seconds. Okay. Last 5, 4, 3, 2, 1. Okay, I would say this is a little tricky, half of you all got it right, but for the rest who did not, let's see how are we going to do this. Okay, so what is the first thing or the first number that we can decide straight away? Can anybody tell me? Since we have quite some time actually for this lesson. What can we straight away decipher from these 5 numbers? So let's say I have my 5 numbers over here. 1. So 1, 2, 3, 4, 5. Okay, the mode, okay. Based on the mode, okay, let me get some responses over here. Okay, let me not write median. Sorry, you say mode, right? Let me put the positions of the numbers. Let's say this is 1, this is 2, this is 3, this is 4, and this is 5. Based on what you say, Denise, can you tell me in this case, for the since you say the mode, right? You can decipher the data based on the mode. What will be the numbers for any of these positions here, given that you know the mode? Okay, does anybody wants to try? For those who got it correct? Very nice. Okay, yes, we know the mode is 6, but which position will it be at? Is it number 1, number 2, 3, 4, or 5? Let's think about this. Or in this case, we know that it's 1 and 2. Very good, Denise. Now we know it's there. But you realize you have deciphered it from there. It's because we know that the median, it's bigger than the mode in this case. What happens if my median is 5? It will not be at position 1 and 2 anymore. So actually, that position that gets you to why you know it's 1 and 2, the number 6 is at 1 and 2, it's the first notion over here because of the median is 7. But then again, it's also correct, okay? Just saying because the median is 7, 5 numbers over here. That's why we know that the median 7 holds at position number 3. That's the notion. And from there, we know because the mode is 6. The mode is 6. And of course, because since the mode is 6, we need it to have more of the number 6 appearing, right? So that's why we need at least 2 of them to appear. So that's where we know in this case it will be 6, 6, 7, dash, dash. Okay, that is the first few numbers you can see accordingly already. And we know actually from here, 6, 6, 7, we can eliminate straight away these 2 options. Okay, so that's why reading the question, it's very important to know what we have over here. Okay, median is 7, mode is 6. I think I color coded wrongly. Okay, never mind. Let me just leave it as that. Okay, you know what? Let me just change. Okay, it's alright. Okay, 6, 6, 7. Now, what is another key thing over here that we can do? We need another number. In this case, now we know the mean is 8, but we cannot find the mean because we got 2 unknowns. So one way we can have it is, yes, the blue highlight in the question, that's right. The smallest number is half the largest number. Okay, so what does that mean? The smallest number is half of the largest number. So if smallest number is 6, half of the largest number is 6. The largest number has to be is half, let me just write it down, the largest number. So therefore, we know 6, 6, 7, dash 12. That is what we have because the smallest is half of the largest number. This fits in as 12. Now you realize this still covers 1 and 4. Okay, 1 and 4. But we have yet to find the number 4. How do we find the number 4? Mean comes into play. So that's where we have to use the mean. No choice. And in this case, all the questions data are utilized. So that's why they give all this information. Because without all this information, you cannot get any of the numbers. So what we do now, we just need to find the mean is 8. Means what? Okay, we let this unknown number say be x. Okay, we are finding x now. So 6 plus 6 plus 7 plus x plus 12 over 5 is equals to, mean is 8. If you solve this, at the top we get 31 plus x is equals to 40. We then know that x is equals to 9. So therefore, number 4 is my answer over here. And thus we know this is 9 and henceforth as such. So based on this data, that's why I went through the previous example just now, because you got to know what is the concept of median when you have an odd set or even set of data as well. Just now was even set, I covered odd set as well. Based on the mode, how do we decipher the positions and the median and the other information over here? Okay, so that's one style of question that can come about. Okay, I hope you got this down, because let's move on to mean and standard deviations. Now, over here, what happens, these formulas are actually not so crucial because they are actually given in the formula sheet. In this case, you definitely see them over here. Sum of the data set, and then this is your sum of the frequency, and then you realize this whole thing over here is actually your mean. This whole thing over here is actually your mean. And if we bring it up all here, in this case, this is your sum of the squares. And over here below is the total frequency. Now you realize what happens, you don't really utilize these formulas over here. Okay, again, the formulas are given. Sometimes you might have to express it by putting down the value of the sum of the squares, value of the total frequency, value of the mean if it's 2 marks. But usually in 1 mark, you just need to type in the value. So that's where the calculator skills are important, which will be shown in your next 2 bubble questions. More or less what we are doing here is we have to understand what we are doing when we are calculating the mean. That is very important, because for the later part of the lesson where we have 1 bubble question targeting at that. Let's go through the definition first, and then we see what we mean over here. In this case, okay, that's not a pun, but mean. I think you all got it already just now when we went through based on the example. The top, we need to sum all the data before we divide by the total frequency. Okay, that's the notion over here. Total frequency. Sum of data divided by total frequency. Now, standard deviation, does anybody wants to guess? Based on this formula over here, we have the mean, and based on this data over here, what are we actually doing when we are defining the standard deviation? What are we doing when we are subtracting the standard deviation? What does it mean? Yes, we are minusing the mean, but what are we actually calculating when we minus the mean? What are we doing? Okay, you realize we are square rooting it, because what happens if the data is less than the mean? What happens if the data can be more than the mean? Okay, what we are doing here, let's say given this mean over here, we are actually trying to find out, say for example, okay, let me have a data set. Say 14, 18, 25, 36, 49. Say for example. What we are essentially doing there, suppose we calculate the mean. Okay, I can't mental sum right now. 32, 57, 94, 94, and then 143. So my mean is actually 143 over 5. Sorry, let me just do a little bit of mental sum over here. 24.6. My mean is 24.6. Okay, my mean is 24.6. Sorry for the messy arrangement over here. Let's say this is my mean. What we are doing over here is we are essentially finding out, because standard deviation, how far, in this case, what we are doing is how far each value are away from the mean. How far each value deviates away from the mean. So standard deviation, in this case, measures distance and the distance from the mean. Okay, remember this. When we are taking our calculator, pressing it, standard deviation actually measures the spread of data around the mean. That's why we subtract the mean. Very important over here. Now, going back to standard deviation, you realize that we have 2 types of standard deviation in your calculator. One is this, one is this one over here. Suppose I label this A, I label this B. Can anyone tell me which is the standard deviation we are using over here? A or B? Okay, Denise, that is actually correct. Anybody else wants to try? Which one are we doing over here? Very good, Chen Chen. Anyone else? Which one are we using over here? A or B? Okay, looking at the responses, going good. Okay, the answer is, okay, we use this one. The one at the bottom also is standard deviation, but it's out of your syllabus. You don't have to know it for your context. Okay, just so remember, when you look at your calculator, when you're calculating it, we are using this one, not this one. Okay, and also for the mean, just take note. Okay, this one, there's only one way to check over here. It's actually this one. Take note when you calculate, when you are putting in the value for the calculator, it's this one over here. Of course, you can calculate manually, but usually this kind of questions, 1 mark, we want to make sure you go as fast as possible. So make sure you know what to key in the calculator, which is the notion of this next bubble question. All right, we have 33 students, okay, information is given, and this is a group data. So how do we calculate and key in our values using a group data? You have only 1.5 minutes for this. I know you may wonder, why do we need so long to key in the calculator? And in this case, this is for those who actually want to do it manually. I give them some time. Okay, but then again, 1.5 minutes. Take your calculator, get ready. Don't say I never warn you. Launching the bubble launcher. 3, 2, 1. Let's go. Take note, it's a group data. So what do we actually need to do first to find the values? Very careful. Alright, seeing the first response, that's good. Remember, very careful. What is the data that you need to key in? Last 40 seconds. Alright, seeing the responses, it's all going good. Last 30 seconds. Last 20. Hanging there with me. Okay, looking at the responses, it's going good. Alright, I've toggled between 2 responses, which means you guys are doing the correct notion. Just a little tricky over here. Last 3, 2. Okay, time's up. Let's take a look. Okay, so seeing those 2 responses, I'm heartened. But just take note, okay, very important when we actually do such things. So based on the responses, most of you got the consensus that we need to find the midpoint of each group range over here. Okay, so the midpoint over here, in this case, just calculate 2.5. It's just the average. 2.5, 7.5, 12.5, 17.5, and 22.5. Okay, find the mid-range. But take note, the midpoint value, it does not have to be a decimal. The midpoint value, it does not have to be a whole number. So do not round up and key in the midpoint value. Because when you have your calculator, you are bound to see this particular table over here. Okay, so I'm going through the calculator notion because that is usually the way to do it to save time. You have 2 things. One is the x value, one is the frequency. Key in the x value as it is, because when you do the midpoint, divide by 2, you're bound to have a 0.5 at the end. Key in with the 0.5 at the end. So 2.5, 7.5, 12.5, 17.5, and 22.5. Do not, I repeat, it does not have to be a whole number. Do not round up my value. Key in as it is. From there, frequency, key in as accordingly. 2.5 is 5, 7.5 is 4, so on, so forth. With these values over here, from your calculator, you just need to search for my X bar. This is my mean. X bar in this case is 13.2575. Question never says round up to how much? Exam standard, round up to 3 SF. That's where you get 13.3 minutes over here. Okay, so this is the notion where you need to take note when we are doing such calculations, especially when it comes to mean 1 mark or 2 marks, standard deviation 1 mark or 2 marks, calculator skills have to be there. The extra 1 mark for mean and standard deviation is just to find out what, to key in your workings, so your sum of data and your frequency and the mean if needed, or even for the sum of squares if needed for your standard deviation. Which is, again, this is the answer, and therefore my next question over here, same question, but I want the standard deviation right now. How do I do it? If you still have your previous data set, this can be answered within 30 seconds, but I will still give you 1.5 minutes for those who actually accidentally erase your data. Okay, so I'm going to launch the bubble launcher right now. Launching it in 3, 2, 1, let's go. Alright, take note, what do I want for this particular question? Take note, what are we calculating? Very nice, very good. Okay, take note, what are we calculating over here? Okay, remember the first step? Okay, this is what is done previously, so I'm just going to write it down. Okay, this is what is gone through previously. It's the same question, but what are we essentially finding? Record standard deviation. Which one do we use? I went through this recap just now, so take note. Last 30 seconds. Okay. Last 23 seconds. Right, so for those who are actually manually calculating, you realize time over here might be a bit of a constraint, but for those who have a calculator, you realize this might be very quick. Okay, last 10 seconds I have over here. Last 5, 3, 2, 1. Okay, not too bad. Half of you all got it right. That's good, but some of you still have some confusion over here. So take note, data set, when you key in your calculator, you will still key in as accordingly as X and frequency with my numbers over here. So I have 2.5, 7.5, and so on, 12.5, 17.5, and 22.5. Okay, now frequency over here I have 5, 4, 8, 13, and 3. But now, what value are we finding for the standard deviation? What are we finding? Take note, we are finding, sigma x. Okay, so that's why just now, if you have a previous data set, this one can actually be done in 10 seconds. Because your previous data set, all you need to do from your calculator, you are finding sigma x. We call it sigma x. Okay, this is equals to, take note, 6.0. If you were to do the SX, it will actually give you number 3, which is some of your answer. Or some of you have a rounding error, you give me 6.04 because it's actually 4, 5, 4, 3, 5. Rounding out the 3SF, 6.05 minutes over here. So remember, how do we do this over here? Go to your calculator, make sure your calculator is in statistics mode. Okay, depending, let's say you have in Casio, you will click shift mode, you toggle down until you see the node statistics, then you key in accordingly. Of course, there are also sharp calculators, so from there I will not really go into detail. If you need help for the calculator entry at the end of the session, Q&A, feel free to ask me. I'll be more than happy to help you accordingly. Okay, make sure, but take note, very important, we are calculating for sigma x, not SX. Okay, this is what we do not want. Okay, this is a no-no. We don't want SX. Okay, all right, so I hope this is a little clear. for standard deviation, usually if you realize there is not much time because you go for the formulas, but right now, if you want to utilize time, you have to be very particular on your calculator familiarity, what to key in, especially for standard deviation, because that will help you a lot, and how to check as well. Okay, now following up, you realize for mean and standard deviation, we have next our median, lower quartile, upper quartile range, and interquartile range. So let's do a recap. Median, what percentile is it? What is it equals to? Can anybody tell me? Median is going to be my what percentile? Does anybody wants to try? Okay, so median, middle data, very good, Chen Zheng. Anyone else? Does anybody wants to try? Very nice, giving me the answers for the other two. Very good, Chen Zheng, perfect over there. Okay, so median we know is 50th percentile, very good. Lower quartile, what is it? Very good, that's nice, Chen Zheng. Okay, very good, Chen Zheng, giving me the answer for range, that is good. Upper quartile, what is it? Very good, Denise. Alright, thank you for the note for the lower quartile. Chen Zheng, when you mean upper minus lower, what do you mean? Is it for the range or the interquartile range as we are going on? Okay, that's the correct notion over there. Okay, it has to be that notion. Very good. Okay, and then if you are looking for upper lower, that's good as well. But I would like to call it something else because it's quite a mouthful to say this. Okay, upper quartile is going to be, okay, we know it, 75 range. Okay, highest minus lowest is correct, but what I would like to do is actually, very good, okay, thank you for the note. I would like to call this maximum value. It's a good habit. It's a better word to say, minus minimum value. Now, why would I say max minus mean? It's the same thing as highest minus lowest, but you'll understand what I mean at the next bubble question. All right? You understand what I mean? Interquartile range, upper quartile minus lower quartile, that's correct, but it's quite a mouthful to say, and it's a bit of a length to write. So keep it simple. Q3 minus Q1. Q3 minus Q1. Okay, simple and also easier to write down. Save time. So what do we do with this data for certain questions? So a very simple one. Bubble question 6. This actually shows the waiting time with a box plot. I hope you guys recall your box plot. Okay, this is just a recap over here. I want to actually find the range and interquartile range. How do we do so? Okay, look at this question. Okay, over here, I'm going to give you some time, maybe 10 seconds to read at the data before I launch the bubble launcher. So you can start now before I launch it in the next 20 seconds. You guys can start now. I'll launch it in the next 20 seconds. 10 seconds now. Okay, I'm launching in 5, 4, 3, 2, 1. Let's go. Okay, that's good, that's good. Okay, very nice. Okay, seems like most of you are doing well. Be very, very clear on and know what you're doing for the range and IQR based on this data set over here, box plot. We call it the box plot, or there are many names for it. Box plot, box and whiskers. I think that's it. Yeah, there's not many names. There's only 2 names, all right? So be very careful. Okay, very careful. Take note. What are we reading from? Some of you are actually still not too clear on your range and IQR. Take note. Read the diagram carefully. Last one. Okay, again, read the diagram carefully. Half of you all got it correct. Okay, this should be rather okay. So let's take a close look. Now, recall why I say range. I like to write it as maximum and minimum because in short form, if you read it from the data, each small box over here is 0.5. So it's actually 0, 1, 2. Okay, so this is 1, this is 2, this is 2.5 actually. So 2.5, I can actually label it as straight away short form, minimum. You don't have to spell upper, lower. Again, lesser letters, the better. So maximum minus minimum, upper minus lower, because I write it in the short form, that's easier. And of course, maxima, calculate accordingly. This is actually from the data set 21, 22. This is 22, 22. Okay, so that's where we have 22 over here. And henceforth, this is the maximum. Therefore, what happens? Okay, can anybody tell me, based on this box plot over here, this is the minimum, this is the maximum. What am I calculating over here? In this case, my value over here is 6, 7, 8. My value 8 over here, what am I calculating? Okay, my value 8 over here. In fact, let me calculate for the rest. This is going to be 11, 12. All right. This is going to be, okay, calculated accordingly, 16, 17. All right. So for the value 8, what am I actually calculating? Okay, lower side. So it's going to be my, all right, very good. Okay, I see some answers. Q1, very nice. Next one I have, this is going to be my Q3. And lastly, 12 is going to be the median, also Q2. So recall this is how we our box plot. This is always going to be this case. My extreme ends, minimum, maximum. The other not so extreme ends, Q1, Q3. In the middle, it's Q2. So once you have it, the formulas I recapped previously. Range is just none other than my maximum minus minimum. So that's where I have 22 minus 2.5. This is going to be 19.5 minutes. Okay, recall in this case, depending on the context, they might not be units, but in this case, units is needed. So I write this way. IQR is going to be Q3, which is 17, minus Q1, which is 8. Okay, this is going to be 9 minutes over here. So therefore, this is number 3. Alright, some of you all mixed it up, maybe taking Q3 minus minimum for the range, or maximum minus Q1 for the range, IQR. You have the fanciful formulas and just trying your luck. So be very careful, and some of your reading error, so this one I will not fault you, but just be very careful over here of how the units are formed in my box plot. Okay, now moving on, okay, to our last 2 bubble questions before we call it a day. Alright, so now we are well equipped. I hope you are well equipped and identifying, knowing your different statistical diagrams that appear. Okay, box plot might be one of them. Statistical diagrams that appear. How to calculate your average, and with that, how do we link to standard deviation? Alright, but take note, we are only calculating, and also the measures of spread, your maximum, minimum, Q1, Q2, Q3. That's what we have. But right now, okay, knowing how to calculate is not enough. Usually in statistics, they will ask you to analyze certain stuff. So what do I mean? So that's where the statistical data analysis part comes into play. And we have this question over here. So this is an example of how we need to analyze this particular bar graph and see what can be misleading over here. Look at it carefully. You don't need too much time. You don't need workings over here as well. Gonna launch it right now in 3, 2, 1. Let's go. Alright, this is actually a Sec1 graph over here, so it should be okay. Okay, you don't need too long. Look at it carefully and state what aspect of the graph that can be misleading. Look at it carefully. Alright, that's good. Seems like most of the responses are going well. Read it carefully. Very nice. Most of you got it. This is good. This is good. Okay, this is good. Take note. Look at the question. Look at the diagram. You have about 15 seconds left. Alright, last 5. Okay, so all of you are doing so good, doing so well. Okay, so most of you got it right. Okay, we know in this case, if I don't start my vertical axis from 0, now the gap over here is very, very big, it seems. It seems like from January to February, there is a huge increase in expenditure. But I start from 200. If we actually draw the graph down, there's going to be an increase of 200 for both. The proportion here may seem very small, which essentially explains this. Then you may wonder, is it as simple as this? Okay, let's take note. The other explanations here actually are the things that may evaluate certain aspects of the graph that's misleading. So in this case, when you look at the bar graph, there may be instances where the bar has a different width. Over here is the same, that's why this is not correct, but this is a possible explanation. Bottom, the title may be biased. Again, this is a neutral title, so it's okay, but it is a possible way to suggest that the graph is misleading. Third one, the scale is not uniform, which is another possible way to explain a certain aspect of the graph that's misleading, but in this case it's uniform, that's why it's not correct. Then again, all these four explanations are actually a possible way to explain the aspect of the graph that may be misleading. Okay, but then again, because this is not displayed here, this is not displayed here, this is not displayed here, that is why these options are wrong for this question. But all four of them are possible explanations for certain questions depending on context. Okay, last thing I take note before I move on to the last bubble question, we have to say this word vertical axis. Remember, okay, we cannot say y-axis, x-axis, okay, because my vertical axis says monthly expenditure on transport. It does not say y. And similarly, henceforth, for your horizontal axis, we have say we can say we must say horizontal axis. We cannot say x-axis because this is not labeled x but the month. Okay, Denise asked an example of a bias title. Okay, maybe for this one it's a little bit hard. So let's say I want to have let's say I have a pie chart. Okay, let me draw a pie chart of a phone. And people choose like certain phones. So let's say this is iPhone, this is Huawei, this is Samsung, and this is Oppo. Say for example, I'm just knowing these 4 phones. Let's say they only, in a class they only use these 4 phones. And the title of this particular pie chart is iPhone is the best. Doesn't this sound wrong already? Because when iPhone is the best, it means what? It tells you, oh, that means if iPhone is the best, most of them will use iPhone. So this is how, in particular, a title affects how certain perceptions may be sort of inscribed into people. Okay? But in this case, for this one, can I say, okay, maybe for this one, I can even change my title. Okay, instead of Kate's monthly expenditure on transport, it can be, an example of a bias title can be Kate spends a lot in February 2018. Immediately we look at the graph, we're like, oh, okay, so February she spent the most. Even though it's true, but the title, it's very misleading. So that's one thing. Okay, I don't think you all can see the title. Okay, so let me write this out. I think it's a bit too high, so let me erase this part. Okay, maybe Kate spends a lot. Okay, then let me just write it out. Expends it here in February 2018. As long as it is skewed towards one part of the data, that means it's not accurate already. Okay, so a lot of examples over here. Okay, so I hope this gives a clearer insight. And lastly, to our last bubble question. This example, or this last bubble question, actually tells us whether you understand what mean and standard deviation applies to questions. Alright, so look at this carefully. You have 2 minutes, last one to finish off, launching it in 3, 2, 1. Let's go. Right, so if you know your mean, if you know standard deviation, through this application, you will know how we apply this. You can read it carefully, slowly as well. Alright, very nice. First response down, that's good. 1 minute more. 1 minute, 30 seconds more. 30 seconds is a lot. Okay, I think I will need to spend some time explaining this. So, but hang in there with me. Alright, you have about 1 minute left. "45 seconds." Okay, responses coming in, that's good. Okay, for those who are actually not of Sec 4 and are in my lesson, you might find this a little bit hard to understand because of the notion standard deviation, but do give it a try. Last 20 seconds. Last 10 seconds. Alright, last 5, 3, 2, 1. Okay, I would say most of you got it, but most of you didn't, so let me take some time to explain this. Okay, of course, in exams, this set of questions won't come out, they won't tell you the true statement, but they will ask, okay, based on the data above, state what can you say, state one observation that you can explain between traffic light X and traffic light Y, and then maybe say one about mean and standard deviation. So that's where you have to identify, when we say mean waiting time, based over here, are we talking about in general, whether the waiting time, take note of this word, in general, okay? When we talk about average over here, that's a hint. We have to say the word here, in general, because we are taking the average, so we are looking at the wide span and we are just looking at it in a whole view, so it's in general. So when we talk about mean waiting time, we are talking about, in this case, in general, which one has a longer waiting time. So therefore, looking at it, traffic light X has a longer waiting time in general. And then what happens? Traffic light Y has a shorter waiting time. So looking at this, we know, if you look at number 1, traffic light X has a longer waiting time in general because the mean waiting time is greater. So in this case, this statement is correct because it identifies that mean waiting time in general is longer. That's why number 1 is correct. Whereas number 4 is not correct because we are not using the standard deviation to compare. Mean data set, we use, in this case, the waiting time in general. Then you may wonder, what is the standard deviation used for? Recall, for the standard deviation is the spread of data around the mean. If my data is nearer to the mean, it means my data is actually not so far out from the mean. Henceforth, when I actually try to organize the data, it's actually, in this case, the word here, more consistent. Okay, lower standard deviation, more consistent. Even though it's lesser, because lesser the standard deviation means it's more concentrated to the mean. Henceforth, if I were to look at the data, it's more consistent, because that means the data are closer to each other and closer to the mean. And therefore, in this case, the greater the standard deviation, my data is less consistent. Henceforth, if I were to look over here, this explains what I want to say. More consistent, standard deviation smaller. And looking at that, you realize for the other one, less consistent, less consistent, as the mean waiting time is greater, not a correct comparison. So that's why this is not correct. Henceforth, it's 1 and 3. So the moral story is you have to know that the mean usually compares in general, overall, what is bigger, what is smaller. And for standard deviation, we are comparing how consistent our data is. Okay? So with that, that's actually it for today. So you haven't tried yourself, okay, give it a shot with the cumulative frequency curve. You realize we didn't cover that. So give it a try with this and with this particular data set as well. It will be all compiled in your formative, so do give a look out for that to see how we can answer this. Again, it's a past paper question, 40 bubbles. Give it a shot. So that's it for today. Thank you everyone for your time. And if you have any questions to answer, feel free to answer that accordingly. Otherwise, bye Denise. Thank you everyone. Stay safe. Until then, this is Teacher Jason signing off. Alright, take care everyone. Bye bye.